In section 3.3, we're going to be using algebra to simplify trigonometric expressions. We're also going to be establishing new identities. When we're doing this, we can use any of the identities that we've already worked with, our reciprocal identities, our quotient identities, the Pythagorean identities we have here, like sine squared theta plus cosine squared theta equals 1, or 1 plus the cotangent squared theta is equal to cosecant squared theta, or tangent squared theta plus 1 equals secant squared theta. We also have all of our even and odd identities that we can use, and we're going to be using these things to manipulate these other equations or expressions and show some other identities that we can use. So for example, here we have sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta over sine of theta is equal to 2 cosecant theta. And so what we want to do is we're going to use the identities we already have to show something like this would be true. Now some things that we can do along the way, like for something like this, we would need to have a common denominator. Right? And we can use anything algebra-wise. Maybe we would factor some different things, or maybe use FOIL if we're using some of these trig identities. And some steps that we want to go through whenever we're establishing identities. Number one thing is we're going to manipulate the larger side, or the bigger side. It just gives us more to work with. So for example, on this one we would manipulate this side just because we have more things to work with, and we're going to try and make the one side equal the other to show that those things have to be true. And one of the steps that we're going to do in this is try to use substitution. If there's something that you know is equal to another value, let's plug it in there and see if we can, again, manipulate and try and make them equal to each other. And the biggest thing, once we get going with this, is we can try substitution, and then after that you want to try again, and you want to try again, and you want to try again, and be persistent. Because these things, they just are going to take some time, and we have to get used to seeing different things and trying to identify, hey, what is it that's going to help me get to the end? So as you're going through, just always remember, hey, this is where I'm going, this is what I'm trying to get to, and so what can I do on this side to help me get there? Okay, so back to this problem, we have sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta over sine of theta is equal to 2 cosecant theta. And we're only going to manipulate one side. And if I'm going to add fractions, I have to have a common denominator. In which case I would multiply top and bottom here by sine of theta. And I would multiply top and bottom here by 1 plus the cosine of theta. So as I multiply here, I get a sine squared theta over, and we would write that as, let's just keep it as sine of theta times 1 plus cosine of theta, plus, now when I multiply here, this is where we're going to, we have these two quantities. Alright, so I would FOIL, and I'd have 1 plus 2 cosine theta plus cosine squared theta all over sine of theta and 1 plus cosine of theta. And this is all still equal to 2 times cosecant of theta. And we're going to keep that side the same. So now from here, we could write it all as one fraction. Sine squared of theta plus 1 plus 2 cosine theta plus cosine squared theta all over our common denominator. And anytime you see a sine squared and a cosine squared, that's one of our Pythagorean identities. So if I take the sine squared theta plus cosine squared theta, I know that equals 1. So this is where I would substitute in 1 for that. So now I have 1 plus, now I have this piece, 1 plus 2 cosine theta all over our common denominator. Now 1 plus 1 is 2. So now we have a 2 plus 2 cosine theta. I can factor a 2 out of that. So as I write that, we have 2 times the quantity of 1 plus cosine of theta all over sine of theta over 1 plus cosine of theta. So those two quantities would cancel out. So we're left with 2 over sine of theta. And we know that sine of theta is a reciprocal with cosecant. So 1 over sine of theta is equal to the cosecant. So what we now have is 2 times the cosecant of theta equals 2 cosecant theta. And now we've established that this would have to be true.